Go. Hi, Don. Say hi, Don. Good boy. Welcome back, 4th grade. Today we're going to be focusing on comparing the different representations we've been doing. So we've done the dot plot, we've done the frequency chart, and we've done dot plot, frequency chart, and stem and leaf plot. And we're gonna try now to take those and compare them to one another, see if we can like take a stem and leaf plot and turn it into a frequency chart, or take a frequency chart, turn it into a dot plot, or take a dot plot, turn it into a frequency chart. We're gonna do all those different things with it. And before we get started with that though, I wanted to talk about some major characteristics of these that I might not have, or that I didn't mention before. So one thing I wanna note is when we look at dot plots, and when we look at frequency charts, they're very, very similar. And I wanted to point this out, that like a dot plot is it's like kind of the same layout as this, except for one is vertical and one is horizontal. So as soon as I go like this, it's almost like a dot plot. So this almost becomes a dot plot in a way, where like 2 has 1 dot above it, the 3 has 2 dots above it, and so on and so forth. So these like tally marks kind of become like the dots that are above the numbers. So that's like one thing that is really important to notice, that these two, like the frequency chart and the dot plot, are super similar. They're just one uses like dots to measure it or to show the data, where the other one uses tally marks. Or as we also saw, it could also use actual numbers as well. Instead of like writing 3 tally marks, we can actually write, like this one, we can actually write that number there, where instead of like, you know, doing 2 tally marks there, it's just the number 2. So I wanted to point that out, that frequency charts and dot plots are like this. They're like best friends. The stem and leaf plot, however, is kind of its own unique thing. So typically, we're not gonna try and take data that's in a stem and leaf plot and try and put it into a frequency chart, or try and put it in a dot plot. And the reason is because is for data that is spread out. So what I mean by spread out is, I mean like it might go from like 2 to 50. Like that's your data. You could have a 2 and you could have a 50. You know, you could have 2 dogs, you could have 50 dogs. That's not a good example, but you could, you know, that data spreads out quite a bit. Whereas when we have something like this, we wouldn't want to go from 2 to 50. That would be so many little like hash marks there that just, they don't make sense. This is much better. This number line format is much better for smaller ranges, from like 10 to 20. Like that's a pretty small range. It's only like 10, you know, numbers in between there, whereas, you know, 2 and 50 is kind of large. But that's what that stem and leaf plot allows you to do. It allows you to represent data that's got like that big difference. Like this one goes all the way from 81 to 125. And that, like, I mean, I could put that on a number line and I could represent that using a dot plot, or I could do that in a frequency chart. It would just, there would be so many little steps, so many little like hash marks on the number line, or so many different like columns in that frequency chart to represent, you know, 80, 81, 82, 83, 84, 85, all the way to 125, and that would just be ridiculous. And so the stem and leaf plot is going to be great for when you have data that has like a large range, when it, you know, it goes from small numbers to big numbers, or whatever it is, when there's lots of space in between that. And the number line, or sorry, the dot plot and the frequency chart are gonna be much better for smaller ranges, where it's like, well, most people are gonna have between 2 and, you know, 7 people living in their house. That's pretty typical. And that you don't need a stem and leaf plot for, because there's not enough variation in that. It'd be kind of a boring stem and leaf plot. You could do it, it just wouldn't be as helpful. So that being said, remember, stem and leaf plot is kind of its own thing that you can connect to dot plots and to frequency charts, but really those dot plot and frequency charts are like buddy-buddy, they're best friends, and those two go really nicely together. So I'm gonna focus more on those two, and then I'll probably do one, and then I will just do one with the frequency chart, just because it's not as common. So we can begin. All right, so we are gonna start today by taking our frequency chart and turning it into a dot plot, okay? So we're gonna start here by reminding ourselves that these two best friends, right? They go hand in hand, they work really nicely together. And I'm just gonna remind you that in a way, as we make this dot plot, we're basically gonna be taking this frequency chart, and each of these tallies is gonna kind of become a dot in a sense. So that's how we're gonna check our work at the end, is I'm literally gonna flip it so that I can match it up and see if it works, okay? So this is how we make it, this is how we like go through though and make each of these dots, and how we like take the data from here and bring it here. So we have here 20 to 26 pickles per jar. That dash means per jar. And then this tells us how many times that happens in the data. So 20 showed up one time in the data, so that means I can put one pickle, one dot over here. 20 has one dot, just like 20 has one tally. 21 has two tallies, which means 21 should have two dots. And again, I'm going to remind myself that all the ones should kind of line up together on this line to choose. They should all kind of be in line. You don't want to like make your dots really zigzaggy. You want to make sure it's clear that two dots is more than one dot, so that second dot should be higher. 22 has one dot and one tally. 23 should have four dots because it has four tallies. 1, 2, 3, 4. 24 should have two dots. 1, 2. 25 should have one. And 26 should have one. And there we have it. I've taken everything from over here and put it onto a dot plot. And again, when I flip this now, it should match up pretty well. It should kind of flow nicely for us. So again, we got 20 has one dot, one tally. There's two dots, two tallies. One dot, one tally. 4 dots, 4 tallies. 2 dots, 2 tallies. 1, 1. And matches up just like that. So that is how you can take a frequency chart and turn it into a dot plot. All right, now we're gonna do the same thing here the opposite thing here, where we're gonna take a dot plot and we're gonna put it into a frequency chart. Again, these two are best friends, they're best buddies, and they are gonna work really nicely together. And kind of what's gonna happen is this frequency chart, or this dot plot over here, is just kind of gonna be turned and will match up here with tally. So each of these dots will become a tally, okay? So I had a number line here that went from 10 to 20. When I put it over here, I'm only going to go from 10 to 18 because the 19 and 20 didn't have any, so I don't need to include them at the end. I include the 13, the 16, and the 17, even though they don't have any, but that's because they're in between some dots, so I would include those. But I'm going to just kind of cross off those two at the end. So I'm going to go like this. I'm going to put 10, 11, 12, 13. All right, so we're going to go through. Starting at the least one here, 10 has one dot. That means 10 occurred one time in the data. That means one person watched TV for 10 hours. So I'm going to put one tally. The 11 people watched TV, or I'm sorry, 4 people watched TV for 11 hours. 1, 2, 3, 4. 3 people watched TV for 12 hours. There's 3 dots, so there should be 3 tallies. I can skip 13. I do not put any tallies here. I also do not put a 0. I just leave it blank. 14 has one tally. 1 dot, 1 tally. 15 has 1 dot, so that's 1 tally. 16 and 17 I can leave blank. Again, I do not write 0. I just leave it blank. And then 18 has 1 tally as well. I'm going to kind of finish off our chart here. Okay. Again, I should be able to check this by kind of turning this way and matching it up. So I should see that same flow, where do you see how it kind of gets bigger here and then it goes down and then it gets a little bigger? See that little like flow? That flow should happen over here too. Notice how there's like a big spike and then it goes down and there's a little bit more, just like that. Again, that 10 has 1 tally, 1 dot. 11, 4 tallies, 4 dots. 12, 3 tallies, 3 dots, and they should all match up, right? I could also take this and flip it this way, as I did before, and I should see that same pattern happening. I should see that same thing going on. Look at that, almost lines up perfectly. Where each of these lines up, right? Nothing in the 13, 1 in the 14, 1 in the 15, nothing in the 16, nothing in the 17, 1 in the 18, all right? So that is how you take a dot plot and turn it into a frequency chart. All right, so like I said, I was going to give you an example of a time that the stem and leaf plot was paired with a dot plot. This won't happen very often, like I said, because, I mean, it can happen, but typically dot plots show smaller ranges of numbers. Like typically a dot plot only goes from like 16 to 26 or something like that, where it's like a smaller amount. Not that it can't be spread out and be longer, it's just like notice all how many more lines there are drawn here rather than making it smaller. So again, this isn't impossible, it's just not quite as common because this is great for large amounts or like a large range in numbers, whereas this works best if you don't have to draw a whole bunch of tally marks. But like I said, still possible. So we're going to try it out here with cost of sheets at Walmart, okay? So all of these dots represent some different sheets that you could buy at Walmart, for example. And so like this is 16, so this is 17, 18, 19, 20. So I didn't mark all of it. I only marked the evens because again, it kind of gets difficult to draw a number line like this because there's just so many numbers that you would have to write. And so to kind of split it up and not write them all is kind of helpful to keep it clean and neat. So I'm going to show you how we're going to do this. So again, we want to remember that when we do stem and leaf plots, what we're doing is we're taking that smallest place value and putting it off on the leaf side so that we're just left with that, the larger place value over here, okay? So we have from 17 to 33. So that means that our lowest place value is going to be, our smallest place value is going to be the ones place. I don't see any decimals here, so it's just going to be the ones place. And then our highest place value is the tens place. And so that's kind of how this is going to be split up. We're going to have tens and ones. So that means when I see 1 line 7, that's going to mean $17. Oopsie. $17. Okay. So here we go. We're going to start working our way through. So I'm going to start with the 1 in the tens place. And so this is going to be 1 line 7, and then this next one is 19. So again, we still have a 1 in the tens place, so it's going to be 1 line 9, and then we go to 20 next. So that means that I'm no longer in the ones, I no longer have a 1 in my tens place. I have to go to a 2 and make a new row. Again, these have to go from least to greatest, so I want to make sure, so this goes from least to greatest, and these also go from least to greatest. So I have 2 20, so that means I have to do 2 0 twice, 20, and then 20 again. The next one in my row is 23, and it looks like I have 3 dots above 23, so that means I need to have 3 23s here. 2 3 2 3 2 3. Okay, and then finally I have 24, and just one of those, so we just write 1 for it. 24. Okay, 30 is the next one, so that means we no longer have a 2 in the tens place. We now have a 3 in the tens place, and I have, looks like 1 2 3 4 5 30s. So that means I need to have 5 zeros here because I need to make 30 5 times. 30, 30, 30, 30, 30. Okay, and then I have 32, so I need to make 32, and then finally 33. Kind of almost ran out of space there. But what we've done is we've taken our dot plot and turned it into a stem and leaf plot. And this was helpful for us because it reduced the amount of times that you have to write the 1 and the 2 and the 3. And it's just like, hey, you know, instead of writing out all these numbers, you can just know that 1 is attached to each of these, and you can know that 2 is attached to each of these without actually having to write the 2 by all of those. It's kind of what it does. It reduces that writing for us. And again, we got least to greatest, and then each of these is also least to greatest as we go. We can check out our work by counting up all the dots here and making sure it matches all the leaves. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 pieces of data. So I should have 15 over here as well. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Awesome. And then I can do that other check too, where it's like, you know, if I have 2 pieces of data in the ones row, then that means 2 of my dots should have ones in the tens place. So I have 17 and I have 19. That checks out. 1, 2. 1, 2, 3, 4, 5, 6 should be in the 20s, right? 1, 2, 3, 4, 5, 6 should be in the 20s, and then I should have 5, 6, 7 in the 30s. 1, 2, 3, 4, 5, 6, 7. So that, oh, excuse me, that all checks out as well. So, like I said, this won't be as common. Typically, this is going to represent a large range of numbers, whereas a number line, that would be exhausting to have to write out all of the range of numbers. So typically, number lines represent smaller ranges, and this is better fit for large ranges. But as you can see here, it totally happens. It totally works. So there we go.